Welcome again. Oscillation of mass attached to a horizontal massless spring, lecture 3. So let's consider a spring having negligible mass attached with a mass m on a frictionless horizontal surface. Okay, the surface has no friction, and this m is at equilibrium and x is 0, equilibrium position. Okay, let's suppose I apply a force on m and stretch towards my left through distance x. The stretch produced in the spring due to external force, I feel an opposite force in the spring towards my left. See, when I apply force to my right, I am applying external force in right direction, and internal force is developed in the spring which opposes my external force. Okay, now if I compress the spring towards my left, applying external force to left, again internal force exists in this coil towards my right, which are opposing my external force. This force is known as spring force. Alright, when x is equal to 0, when the spring is in equilibrium position, there is no stretch in the spring. Let Fx be the external force to the spring when I stretch through x. Alright, this is the stretch x produced in the spring. There will be the internal force in this spring which opposes to my external force. This force which comes into play is known as spring force. Alright, or restoring force. Let's check mathematically. When I apply external force, it will be proportional to stretch. That means the more I wish to stretch the spring to my right, the more I have the opposing force. The more I stretch, the more opposing force or the spring force. But the more I try to stretch, the more I have to apply some external force. So external force is directly proportional to x. And now as you see, this spring force is opposite to this external force. Alright, that means this spring force and external force are equal and opposite to each other. So they are equal but opposite to each other. That's why I have put the minus there. Alright, also when you try to disturb from equilibrium position or try to stretch, the spring force will be proportional to x. Alright, or you can see that the spring force is negative times x, or spring force is minus k times x. Alright, this k is constant. This is known as spring constant. Alright, so this is negative time displacement. Okay, Hooke's law. Hooke's law states that the stretch produced in the spring is proportional to applied force, or it is proportional to restoring force. So restoring force is minus k times x, or restoring force is directly proportional to the stretch produced in the spring. This is the mathematical form of Hooke's law. Okay, so Fs is minus k times x. Alright, let's see whether it oscillates when I stretch it towards my right or when I try to compress it towards my left and let it go. Suppose I stretch it and let it go, it starts oscillating about x, about its equilibrium position. This oscillation, let's check whether it is simple harmonic oscillation or not. Okay, alright. So the force, external force, or the force is called mass into acceleration. It will be equal to mass differentiation of x dot, that is equal to mass into x double dot, which is equal to minus kx. All right. So x double dot mx double dot is minus kx, or x double dot is equal to minus k over mx. This km and our constant, spring constant, m is the mass. Let k by m is another constant, omega square. All right. So x double dot is minus omega square x, where omega square is constant. So x double dot is proportional to negative times x. So acceleration negative times displacement or stretch in the spring. So this is simple harmonic motion.